Hello. If the ducky is moving around, we say that it has kinetic energy. Ke is equals to half mv squared. If the ducky is sitting on top of a table, we say that it has potential energy because GPE is equals to mgh. Now, what if the ducky is just sitting motionless on the floor? Does it mean that it has zero energy? Not really, yeah? Because if you zoom in, then at the microscopic level, you realize that all the atoms or molecules in the ducky are doing this jiggling motion. So every vibrating atom or molecule has Ke. Besides that, between every pair of atoms or molecules that are bonded together, there is potential energy. To be specific, is the electric potential energy due to the chemical bonds between them. So if we add up the kinetic energy of every single atom in the ducky, we get this term here, the microscopic Ke. And if we sum up all the potential energy that arises from every intermolecular bond, then we have this term here, microscopic Pe. The summation of all this is called the internal energy. So the internal energy, which is usually given the symbol U, is equals to the summation of all the kinetic energy and potential energy at the microscopic level. Now let me highlight to you that the average microscopic Ke is directly proportional to temperature. So temperature is not about how much internal energy you have, it's not about how much microscopic Ke you have, it's not even about how much total microscopic Ke you have. It's about the average kinetic energy of the individual atoms in the body. Let me also highlight to you that an ideal gas would have zero microscopic Pe, because in an ideal gas, all the atoms or molecules are completely free from one another. There's no intermolecular bonds to talk about. Now, if you bring two rubber duckies together, then it's possible for internal energy to be transferred from one ducky to another. So what decides the direction of the energy flow? It's about who is at a higher temperature, right? So the big ducky probably has more internal energy than the small ducky, simply because it has more atoms or molecules. However, if the molecules in the small ducky are vibrating very vigorously, and the molecules in this big ducky are vibrating not so vigorously, then this is the hot ducky and this is the cold ducky, and heat must flow from the hot ducky to the cold ducky. Okay, so now why don't you see whether you can differentiate between these three quantities? So the internal energy is just a summation of all the Ke and Pe of individual atoms in the body, and temperature is the average Ke of all those atoms or molecules, and heat is the transfer of internal energy from high to low temperature. So notice heat is not the same as internal energy. So it's not correct to say that this ducky has more heat than this ducky, but it would be correct to say that because the atoms or molecules in this ducky has a higher average Ke, heat flows from this hot ducky to the cold ducky. Alright, that's all. Ta-ta!